Our next lesson in the atomic structure and nuclear decay unit is a continuation of the previous lesson on isotopes. We will look at a few more specifics about how we deal with isotopes and subatomic particles. The learning target we are focusing on for this lesson is to determine the number of subatomic particles in a given isotope. Before we take a look at how we'd go about doing that, let's just recall a few things from the previous lesson. For each question, please pause the video, answer it, and then see how well your answer matches mine. Question number 1. What is an isotope? From the previous lesson, we learned that isotopes are atoms of the same element with different numbers of neutrons. Question number 2. What is a mass number? We learned that a mass number of an atom is the number of protons plus the number of neutrons in the nucleus. So we just add them together and that gives us the mass number. Question number 3. How do we differentiate between isotopes of a given element? Isotopes are designated by their respective mass numbers. So for example, if we have two isotopes of the same element, for example, let's say chlorine 35, chlorine 37, those numbers 35 and 37 are the respective mass numbers of those isotopes. We wouldn't even have to be talking about isotopes of the same element. For example, we could talk about chlorine 35 and bromine 70. We wouldn't have to have the same element. We could still refer to the mass numbers of those isotopes. Question 4. Write the symbol for a boron atom with 6 neutrons. So looking at your periodic table, you will see that boron is atomic number 5, so it has 5 protons. And so I take the number 5 protons plus the 6 neutrons that it contains that we're told, and that gives us 11. So the mass number would be 11, and the symbol then, we would write, the symbol for the element boron is capital letter B, and the mass number goes as that superscript on the left side there, and you can see it, we'd write it as so. So let's put this all together. There's going to be a chart here that'll pop up. I'll just go ahead and click again so you can see it. You will be given at least one piece of information for the chart, and then you need to fill in the rest. Now assume all the atoms are neutral. If you recall what that tells us, then is that the number of protons must equal the number of electrons. So let's just do a few examples here together first. So the first one we have here is lithium 7. So based on that, we should be able to fill in everything else here. Well, the first thing I'm going to do is I'm going to find lithium on the periodic table, and you'll notice it is atomic number 3 there on the left side towards the top. And if it is atomic number 3, that tells me there are 3 protons in the nucleus, and because it's neutral, that also means there has to be 3 electrons. Now, recall this number 7 we see here, that is the mass number. That is the mass number of that particular isotope. So we can just fill that in, 7. And then the neutrons, recall that the protons added together with the neutrons must equal the mass number, because that's what a mass number is. So ask yourself, how would I get the number of neutrons? And of course that would be just simply subtracting my mass number and my number of protons. So 7 minus 3 is 4. So I would have 4 neutrons in this atom. Let's take a look at another one. So now we're given some different information. We are given the number of electrons. We're given the mass number. Well, recall again that the number of electrons must equal the number of protons because we have neutral atoms. So I have 9 protons. And if I have 9 protons, that means my atomic number must be 9. To get the number of neutrons, notice this is the same scenario we just had in the previous example, where we have the mass number and the protons. So the difference between those two will be the number of neutrons. So 19 minus 9 is 10. And then to determine our isotope, we need to look at the periodic table, find atomic number 9. You will see, in fact, that it is fluorine. So this is fluorine 19. An important point to be made here is that this is fluorine 19, not because you see the atomic mass on the periodic table as 19, but because this particular isotope's mass number is 19. It's just a coincidence that the atomic mass and the mass number of this isotope are the same. Alright, let's do one more together here. So again, we're given something different. This time we are given protons and neutrons, but we can still determine everything else based on that. So like we've been saying, if we have 25 protons, that means we must have 25 electrons because we have a neutral atom. And if we have 25 protons, that means our atomic number must also be 25, because that defines what our number of protons is. Okay, so to get our mass number this time, this is the first time we have not been given the mass number. We simply need to add our protons and neutrons because that's what our mass number is. Mass number is the sum of the protons and neutrons. So 25 plus 29 is 54. And now I need to look at the periodic table and I need to find atomic number 25. And you will see that it is manganese. And so this particular isotope is manganese 54. And again, that 54 is the mass number that we already determined. Alright, I'd like you to try this more on your own now. So here are three others. I've given you some information on each of the three. Go ahead and pause the video, try to do it yourself, and then once you've done, play the video and see how well you did. Alright, so this first one here, we're given gold 197. Okay, recall this notation gives us the exact same information that this notation does up here in the first three. So if you look at your periodic table, find the symbol AU, you'll see that's gold. And remember, this 197 is the mass number. So gold has an atomic number of 79. That's just straight from the periodic table, which also means we have 79 protons. We have 79 electrons. Now we are given the mass number in the symbol there. That mass number is 197. And so to get our neutrons, recall that is the difference between the mass number and the protons. So we simply subtract 197 minus 79. That will give you 118. Alright, next one here. We're given the atomic number, the number of neutrons. So recall the atomic number, in this case 36. That is just equal to the number of protons, 36, which also has to be the number of electrons. So that's 36. To get our mass number, we're just going to add the protons and the neutrons. So 36 plus 41 is 77. We now look at the periodic table. We find atomic number 36, and we see that is in fact krypton. And so this is krypton 77. You can write it like this, that you see here with the symbol. You could also just use the name, write out the name, and then dash 77. Either one would be correct. And finally, we're given mass number and protons. So we have 47 protons. That means we must have 47 electrons. And the fact that there are 47 protons means our atomic number must be 47. To get our neutrons, that is the difference between the mass number and the number of protons. So we subtract. So 109 minus 47 is 62. And then we look at the periodic table. We find atomic number 47. You will see that is silver. So this is silver 109, the symbol Ag. Alright, a few review questions here. Again, as each one pops up, please pause the video, answer it yourself, and see how you did. Question number 1. Determine if each statement is true or false. Explain your answer. Actually, all of these are true false here. Alright, so first one. Nitrogen 14 has the same number of protons as nitrogen 15. The answer to that is true, and this is because we're dealing with the same element. The atomic number of nitrogen is 7, thus all nitrogen atoms contain 7 protons. Whether it's nitrogen 14, nitrogen 15, nitrogen 78, that doesn't exist, but if there was one, if it's nitrogen, it has to have the same number of protons as other nitrogen atoms. Alright, next one. Nitrogen 14 has the same number of neutrons as nitrogen 15. That statement is false. These two isotopes of nitrogen must contain different numbers of neutrons because they have different mass numbers. This is what differentiates one isotope from another. So this nitrogen isotope is a mass number of 14, so it's actually going to contain 7 neutrons because 7 protons plus the 7 neutrons would give you 14. Nitrogen 15 would contain 8 neutrons because it has 7 protons because it's nitrogen plus the 8 neutrons would give you 15. And then finally, nitrogen 14 has the same number of electrons as nitrogen 15. This statement is true. Again, assuming both atoms are neutral, then they have to have they both would contain 7 electrons, since they both have 7 neutrons because they are both nitrogen. So in this video we have looked at how we determine the number of subatomic particles in a given isotope based on our rules: atomic number, mass number, numbers of protons, neutrons, and electrons. Just remember, as you keep those in mind, as long as you can remember atomic number is the number of protons, and as long as you can remember the mass number is protons plus neutrons, typically you will do quite well on these sorts of questions.